Section 13 talks about area. Now, area is very different than perimeter. With respect to this rectangle, the perimeter is how far around. How far around. The area, on the other hand, is how much is inside. How much is inside. Now, if this was 2 feet by 3 feet, the area of a rectangle is length times width. It's say 3 feet by 2 feet. Now 3 feet really means 3 times the foot. 2 feet means 2 times the foot. Well, 3 times 2 is 6. So what do you multiply is up to you. Just multiply everything exactly one time. 3 times 2 is 6, and foot times foot is foot squared. You can read this as 6 square feet. Now, this makes total sense. If this is 2 feet by 3 feet, 2 feet is up and down. This is 2 feet. If I cut it in half, well then each of these will be 1 foot in length. 1 foot. Now from left to right, it was 3 feet. If I cut it into 3 equal pieces, then each piece will be 1 foot. 1 foot, 1 foot. Well, I got 6 of these boxes now. And what do we know about each of these boxes? Well, they're each 1 foot by 1 foot. Each side is a foot long. Oh, if all the sides are the same length, it's called a square. This is a square, and each side happens to be 1 foot in length. Why not define this area to be 1 square foot, which, by the way, is the same as 1 square foot. And you write it either way. Define this area, define the area inside here to be 1 square foot. Oh, we have 6 of them. 1, 2, 3, 4, 5, 6. So it actually makes sense for that area to be 6 square feet. Okay, I hope that clarifies why the area is not 6 feet, but rather 6 square feet. Now, let's talk about a triangle. The area of a triangle is 1/2 times the base times the height. So, if you have this nice little triangle, and I want to call this down here the base, call it B for base, well, how do you find the height? Or visually speaking, what's the height? Well, a triangle, it has 3 vertices. You go to the vertice, or the vertex, opposite the base. These 2, I hope is clear, they're not opposite the base. The other one is, if you were to go down at a right angle to the base, that is, right angle, that's called the height. This distance is the height. So the area is 1/2 base height. That would be the height. For the same exact triangle, if for whatever reason you chose to call that the base. Well, 3 vertices, this is the one opposite the base. Go at a right angle, and that's the height. So, if you are told that this is 3, and this is 4, and this is 7, and you are told that this distance is 8. Well, then the area will equal 1/2 times the base times the height. How much is the base? How much is the height? Well, since this is at a right angle, you should use that height. In fact, that's the only height you're given. Well, then you have to use 3 as the base. Sometimes when you multiply, it's better to say up. And the order you multiply is up to you. 1/2 of 8, I know that, it's 4. Times 3 is 12. Now, one typo is that the base was not 3 and the height was not 8. The base was 3 feet and the height was 8 feet. And now when I multiply the feet by the feet, it's square feet. Now you may say, oh, come on, how can you put square feet into a triangle? You have a good point here. You have a good point. I can say put a square foot here, and maybe another square foot here, and one here, and one here. And maybe I can get one up here, and one up here, and maybe just one more. Well, what about this area? Well, if you took a pair of scissors and you cut it, okay, that is, you start with this sheet of paper. That is, from a sheet of paper, you cut out this triangle. And we're assuming it has the same dimensions as this. And you cut out squares. Okay? You cut off 1, 2, 3, 4, 5, 6, 7. You easily cut that out. Well, then you're left with this and this piece and this piece and this piece and this piece and this bigger piece. That's what you're left with. Well, if you were to cut it and paste it, you would get, well, we cut out 7 already, you will get 5 more square feet. You would actually be able to cut and paste together 5 more square feet. So yes, in a rectangle, in a circle, you can get squares, square units. If you have a circle, you can put in square feet. I meant to stay inside the circle there. In the end, you're going to be left with pieces that you can't just cut out squares from. But if you cut and pasted them together, you would end up with squares. You might end up with a 1/2 square foot. If this is 1 square foot, well then what's below it, what I'm highlighting is a 1/2 square foot. If you think about it, that's a square foot, then this here must be 1/2 square foot. So a triangle can easily be, without even cutting and pasting, a fraction of a square foot, like a 1/2. You get 2 of them, you'll have something called a square foot. A 1/2 square foot plus another 1/2 square foot is a whole foot, whole square foot, which is rather interesting. If you have 2 square feet, each of them are square feet, and I take this 1/2, that's 1/2 square foot, that's shaded in, and I take this here. When you put the shaded parts together, you could, depending upon how you put it together, if you wanted to, you can get a square foot. You can get something that looks like that, which is very interesting. It's very interesting. I just realized that, and I'm like, wow. Now, to convince you that that's true, if I were to do this, everything below that dotted line is this down here. Now, the thing is this piece right here. So now let's talk about what's below the solid line. That is this area. This piece right here is exactly the same as this piece. So all I'm saying is if you have something that looks like this, let me just put this in here. If I cut this away, that is, I cut it right here. I take a scissor and I cut it right here. Well, then I can put it right there, and there's my half a square foot. And now it looks like this one here. Okay, just thought that was interesting. Math is not supposed to be painful, it's supposed to be beautiful. Now, let us consider how we would find the area of more complicated regions. Keep in mind that we only really know how to find the area of a rectangle and a triangle. Okay, so suppose we have something that looks like this, and we're nice enough to be told that maybe this is 15 and this is 15 and this is 7 and this is 8. We want to find the area. Well, we can do this, and we'll do this 2 different ways. 7, 15, 15, and 8. In the top one, imagine I cut it like this. Not cut it. Imagine I partition it like this. That is, I have the top area, which I'll call area 1, which is a rectangle. It's this right here. And then I have the bottom piece, which I meant to write Roman numeral to, is also a rectangle. If I add up the 2 rectangles, I'll have the whole area. Now in the bottom, I could have partitioned it like this. That is, the top left, I have one area, and the right half is the second area. The sum of the areas will be the whole area. So let's do this 2 different times, make sure we get the same answer. We want the area of region 1, the area of region 2. And for argument's sake, let's say everything is in feet. Everything is feet. Well, area 1 is 7 feet by 15 feet. 7 by 15. Okay. 7 feet, I meant to say, by 15 feet. 7 times 5 times foot, which is foot squared. Region 2, not as... Okay, region 2 is a little bit of a headache, because I know this is 8, but I don't know how long this is. But I know the whole thing is 15. They told me that. Those 2 pieces add up to 15. This piece, which by the way is 7, and this piece, total is 15. Well, this is 8. If this is 7, that must be 8. Why? 7 plus 8, 15. So, we now know, though it doesn't match the scale too well, it's 8 feet is 8 feet by 8 feet. 8 feet by 8 feet, why that's 64 square feet. And if you add area 1 plus area 2 is the total area, which I'll denote by 8. And when I add those 2, I get 169 square feet. That problem is done. Bottom. Let's find the area of region 1, the area of region 2, and once we have that, we'll add them, and we'll get the total area, which better be 169 square feet. Now, when it comes to area 1, the top is 15. I know the whole top is 15. But you know what? 15 feet. I don't want to know the length of the whole top. I only want to know this piece. Why? To find the area of region 1, it's 7 feet times this number of feet. Well, that's where the 8 feet in the bottom comes into play. I know that this piece right here is 8 feet. And if the whole thing is 15 feet, why, that must be 7 feet. It must be 7 feet across. 7 feet times 7 feet, that will be the area of region 1, which is 49 square feet. Okay, region 2 is a bit easier. It's simply 8 feet by 15 feet. 8 feet by 15 feet. 8 times 15 is 120. Foot times foot, square feet. Well, 149 plus 120 is 169, in this case, square feet. Same answer as before. Same problem, same answer. You can't calculate the area of something two different ways and get two different answers. And you can, but then you have to realize that at least one of those answers is incorrect. They both can't be right. That either one is right or none are right. You could have made an error in both of their measurements or calculations. All right. Let us suppose now we have a figure similar to the last one, but you have the corner cut off. Corner is missing. Well, once again, we would do this calculation two different ways, and the problem, of course, is to find the area. We're going to do this two different ways, and hopefully we will get the same answer. Now, for argument's sake, make believe maybe this is 5 and 3 and 2 and 8 and 4. And 4 is only up to this corner here. And say the whole thing is 9. But only up to here. So let's number this. 5 and 3 and 2 and 8 and 4 and 9. Okay. Now, what we're going to do is we're going to make believe temporarily that that corner is not missing. The corner is not missing. So there are two ways to find the areas. I can cut it across here, and the top piece will be area 1, and the bottom piece will be area 2, or I can cut it this way. The left piece will be area 1, the right piece will be area 2. And then in the end, I need to take away this area in most of the cases, because that's not part of their area. So what is the area of region 1? What is the area of region 2? And then we would take away the area of the triangular region. The area of region 1. Well, this side is 8. Now, the 2 was only for this piece. The 2 was only that piece. Since I know this is 5, since this is 5, why, that's also 5. 2 is only here, and that's 5. Well, the whole thing is 5 plus 2 or 7. So it's 7 times 8. It's 7 units by 8 units. Whatever the units are, feet, miles, inches, 7 times 8 is 56 units squared. Area of region 2. Well, that one's a bit easier. It's 5 units by 3 units. 5 units by 3 units, that's 15 units squared. And when we add these up, you get 71 square units. But now we want to take away the area of the triangle. Now we have to figure out what the area of the triangle is. I'm just going to use the bottom picture because I didn't draw anything yet. How far is this distance? Well, I know this piece is 8, and it tells me that I got that from here, and this piece is 3. So the whole thing is 11. That is, on the left side, it's also 11. Well, part of it is 9. The remaining part is 2. That is, one side of the triangle is 2. Okay, now let's find the top one. From here to here, I'm told that this distance is 5, and this distance here is 2. I got that from right here. That is, the whole thing is 7. So, 4 plus 3 is 7. So I'm just copying this triangular region over here. It's 2 by 3. Having done that, let me erase everything I pretty much drew. Except I'll leave the length of